Britain's automotive past hides tales of triumph and disaster. Machines that promised greatness often fell short. From ambition to breakdowns, every story has a lesson. Hold on tight as we explore the highs and lows of engineering. Triumph Stag 3.0L V8. The Triumph Stag 3.0L V8, produced between 1970 and 1977, was intended to establish Triumph as a serious competitor in the luxury Grand Tourer market. Designed as a stylish two-door coupe, the Stag featured a bespoke 3.0-liter V8 engine, a collaboration between Triumph engineers and former Rover designers. On paper, the engine promised smooth power delivery and refinement, suitable for a high-end GT. In practice, however, it became notorious for chronic mechanical issues. The cooling system was inadequate, leading to frequent overheating, while the timing chains suffered from poor durability. The aluminum cylinder heads were prone to warping, often resulting in cracked gaskets and oil leaks. Owners frequently faced costly repairs, and many resorted to swapping in Rover V8s to achieve reliability. Despite its attractive styling and capable chassis, the Stag's reputation was irreparably damaged by the engine's failings. Today, the Triumph Stag 3.0L V8 is remembered as a cautionary example of ambitious design undermined by execution flaws, illustrating how even innovative engines can tarnish a car's legacy when reliability is compromised. Rover K-series 1.16, 1.8. The Rover K-series engines, available in 1.6 and 1.8-liter variants, were introduced in the 1990s as a modern, lightweight solution for MG Rover's small and mid-sized vehicles. Featuring an all-aluminum construction with a modular design, the K-series was intended to combine efficiency, smoothness, and adaptability across multiple models, including the Rover 200, 400, and the sporty MG-F, as well as early Lotus Elise units. Despite its innovative design, the K-series gained notoriety for persistent reliability problems. The engine's thin cylinder liners and head gasket design were prone to failure, particularly under thermal stress or poor maintenance, leading to widespread overheating and catastrophic engine damage in some cases. While Rover attempted several improvements, including updated gaskets and revised production techniques, the fundamental issues remained. The K-series became a running joke among enthusiasts for head gasket failure, yet it continued to power a range of vehicles for over a decade. In retrospect, the K-series exemplifies the tension between lightweight engineering and long-term durability, highlighting how ambitious designs can falter in mass production if critical weaknesses are not addressed. Its legacy remains a cautionary tale for engine design and brand reputation. British Leyland E-Series 1500, 1750 Inline 4. The British Leyland E-Series engines, produced from 1969 through the 1980s, were designed to power a wide range of BL vehicles, including the Austin Allegro, Maxi, and Marina. Available in 1500cc and 1750cc inline-4 configurations, the E-Series was an attempt to modernize BL's aging engine lineup with a unit that could fit multiple models and layouts. Drivers often complained of excessive noise, harsh vibrations, and sluggish acceleration, particularly in heavier Allegro models. Fuel consumption was higher than expected for a small displacement four-cylinder, further undermining its appeal. Production challenges and quality control issues exacerbated its problems, leading to reliability concerns over head gaskets and cooling. While the E-Series was technically competent for its era, it became emblematic of British Leyland's struggles to balance cost, complexity, and engineering quality. In hindsight, the E-Series serves as a case study in how a versatile engine can fail to impress when refinement, durability, and user experience are neglected, ultimately affecting a brand's reputation. Hillman Imp 875cc Inline 4. The Hillman Imp 875cc inline-4 engine was an ambitious creation by the Roots Group aimed at competing with small European cars in the 1960s. Drawing inspiration from Coventry Climax racing engines, the Imp's all-aluminum engine was compact, lightweight, and mounted at the rear, which improved weight distribution and handling. The engine featured an overhead camshaft design, offering a higher revving and sportier performance than most small British cars of the era. mass production introduced challenges that affected reliability. Cooling was insufficient, cylinder heads warped, and oil leaks were common, leading to frequent repairs. The rear engine layout made maintenance more difficult, as access to components was limited. Engine tuning and careful servicing could improve performance, and the Imp offered lively acceleration and agile handling for a small family car. The 875cc engine became a symbol of innovation constrained by production realities, showing that advanced engineering alone cannot ensure success if manufacturing and quality control fall short. The Hillman Imp 875cc remains a notable example of British automotive ingenuity and the balance required between design ambition and practical durability. Jaguar 5.3L V12. The Jaguar 5.3L V12 engine, introduced in 1971, represented the pinnacle of British luxury performance engineering. Designed to power the E-Type Series 3 and later the XJ12, this 12-cylinder engine combined smoothness, high displacement, and impressive power delivery for its era. Its V12 configuration allowed exceptionally balanced operation, giving cars effortless acceleration and a refined driving experience. Aluminum alloy construction for the cylinder heads helped reduce weight, while a cross-flow cylinder head design improved airflow and combustion efficiency. Owners valued the engine's silky character with a broad torque curve that made high-speed cruising effortless. Production and maintenance, however, presented challenges. The V12 was prone to overheating if cooling systems were neglected, and electrical and fuel system gremlins could compromise reliability. Fuel consumption was substantial, reflecting the engine's size and performance focus. The Jaguar 5.3L V12 is remembered as a technically ambitious engine that elevated British Grand Tourers, combining innovation, luxury, and power, while highlighting the practical limits of maintaining such a complex and demanding design. Austin Princess T2200 Inline 6. The Austin Princess 2200 Inline 6, produced during the 1970s, was designed to position the Princess as a competent executive car within British Leyland's portfolio. The engine was an enlarged variant of the existing E-Series Inline 4, extended to 6 cylinders to deliver smoother power and greater torque. Aluminum construction reduced weight, but the overall package remained heavy compared to competitors, which limited both efficiency and performance. Power delivery was uneven, with noticeable vibration at lower RPMs and a lack of refinement expected from a 6-cylinder executive unit. Cooling and maintenance presented further challenges. The engine was prone to overheating and required careful servicing to avoid frequent gasket failures and oil leaks. Fuel consumption was high, diminishing the appeal for fleet buyers and private owners alike. The Austin Princess 2200 Inline 6 highlighted the difficulties of adapting an existing engine design to meet higher performance expectations, showcasing ambitious engineering constrained by cost and production realities. Its legacy is a mixture of innovation and caution, illustrating the tension between aspiration and practical reliability in British automotive history. Norton Rotary Twin-Rotor Engine. The Norton Rotary Twin-Rotor Engine was a bold attempt to bring Wankel rotary technology to the British motorcycle market during the 1980s and 1990s. Designed for models such as the Norton F1, Interpol 2, and Commander, the engine used 2 rotors to generate power in a compact, high-revving package, offering a smooth and responsive delivery unmatched by traditional piston engines of similar displacement. The compact design allowed Norton to produce lightweight motorcycles with impressive performance characteristics. Cooling was critical, as the rotary design generated intense heat, and the engine relied on careful thermal management to prevent rotor or apex seal damage. Sealing issues and high wear rates limited engine lifespan, making maintenance intensive and repairs expensive. Fuel consumption was higher than conventional engines, and parts availability posed additional challenges for owners. Despite these drawbacks, the Norton Rotary Twin-Rotor engine remains a fascinating example of British innovation, illustrating the potential and limitations of alternative engine designs. It stands as a symbol of ambition and technical creativity in the motorcycle industry, even if commercial success was limited.